All right, I'm going to go over some questions here because you have failed the Unit 1 test. I'm going to go over some things and show you some of the questions on this test. I want to make clear that the questions are the same each time you take the test. However, they are in a different order. So if I present you with a question, the question number is going to be different when you take it. And also the choices for that question might be in a different order as well. So please get out a piece of paper, write down a few notes so that you can do well in the test when you retake it. And if you don't, then let me know. So first off, there are several questions that just involve multiplying, dividing, adding, subtracting with positive and negative numbers. If you don't remember how to do this, I am honestly okay if you just use a calculator because I know that's always going to be on hand. So if you missed these questions before, you could just use a calculator. The one thing if you want to do it by hand is to remember that when you multiply and divide a positive and negative number, then the answer is going to be negative. If you multiply and divide two negatives, like here, the answer is going to be positive. The next thing I wanted to go over was these types of questions where it's asking you to estimate the answer after rounding. So that's the key. You want to round it first to whatever place setting they're telling you to, and then add it or subtract it. So for example, if I wanted to solve this one here, 418 plus 167, and I wanted to round it to the nearest tens place first, I need to remember this is the tens place. 418 is closer to 420 than it is to 410. And 167 is closer to 170 than it is to 160. So then I just add those two numbers together. Or if I wanted to solve this, but first round it to the nearest hundreds, I look at the hundreds place and say 418, that's closer to 400 than it is to 500. 167 is closer to 200 than it is to 100. And then I add those. If you have a number like the one in blue here, where I want to round it to the nearest ones, like if I have 8.2 plus 4.6, remember the ones place is right here. So you're just basically rounding it to the nearest whole number. 8.2 is closer to 8 than it is to 9. 4.6 is closer to 5 than it is to 4. And then you add them. Prime numbers. So prime numbers are these special numbers that you can only divide by 1 and itself. If it's not prime, then it is called a composite number. So like the number 6. 6 I can divide by 1. I could also divide it by 2. I could also divide it by 3. And I can divide it by 6. So 6 would be a composite number. It's not prime. However, the number 7, I can divide it by 1. And I can divide it by 7. Anything else I divide it by is going to give me a decimal. So this would be an example of a prime number. Least common multiples. So least means smallest. I'm looking for the smallest number that they have in common that are multiples. So what multiples are basically, if I'm listing the multiples of 3, I start off with 3, and then I think, what if I have more than one? What if I have a multiple? What if I have 2 3s? What's that add up to? 6. What if I have 3 3s? I have more. I have multiples. That's 9. 12. 15. 18. You list out the multiples, and then you do the same for 5. If I have 1 5, 5 2 5s, 5 3 5s. Once you've listed out all of the multiples of both numbers, you find the smallest one that they have in common. That's so least common multiple. When you're plotting points, you need to remember you start with the x-coordinate, which is the axis. This is the x-axis. It's always labeled. See, there's an x there. So x is how much you go up or down. Or I'm sorry, left to right. And then you have the y-coordinate. And the y-axis goes up and down. So I always remember that it's always x and then y. Just like in the alphabet, x comes before y. So the first number is how much you're going left to right. The second number is how much you're going up and down. So if I have a point like this right here, this green dot, you start off at the origin where they both, the x and y, come together, and I'm going over 1 to positive 1 and down to negative 2. So I went over 1 and down to negative 2. So that's what that point would be, 1, negative 2. This question is asking what's the coordinate for this dot right here. Square root. There should be a button on your calculator that has the square root symbol, or your online calculator. You press that and then put the number in and then press equals. What square root is saying is what number is being squared? What number is being squared to give you 16? And in this case, it's 4, because 4 times 4 is 16. Okay, so you just put those in your calculator, say what number is being squared to give you 81? What number is being squared to give you 9? With exponents, which I just kind of got to there, if you had 4 to the second power, that is saying 4 is multiplied by itself 2 times. If I had 8 to the third power, that's saying 8 is being multiplied by itself 3 times. If I had 1 to the 100th power, that's saying 1 is being multiplied by itself 100 times. So I know that 1 multiplied by 1 is 1, multiplied by 1 is 1, multiplied by 1 is 1. So I don't have to put my calculator 1 multiply and keep multiply 100 times. I know the answer is going to be 1. I could put in my calculator 8 times 8 times 8 or 4 times 4 and see what that is. But calculators also have the ability to put exponents in. I could just put these problems in orange and press equals, and it should tell me the answer. This is one you can either put in your calculator or ask yourself what's being multiplied by itself, how many times, and do you know the answer? If you have two fractions and you want to know if they are equivalent, if they're the same fraction, maybe one is simplified more, you can do this trick of just cross multiplying. So this question is just saying when you multiply across, 9 times 2 is 18. I want to know if that equals what I get when I multiply across the other way. 6 times 3 is also 18. So that means, yes, these are equivalent fractions. When you are, so now let's talk about fractions. First, the easiest thing to do with fractions is just to multiply. If I have two fractions like 2/3 times 4/5, all I do is I multiply across. 2 times 4 is 8, 3 times 5 is 15. Or if I have the number 4 times 1/8, these aren't two fractions. What I need to do is first change the first one, 4, so it is a fraction. 4 is the same as 4 over 1. Now I can multiply across. Okay, so that's all you do with multiplying. And if you divide, this is like the second easiest thing you can do with fractions. If you divide, you first change it to a multiplication problem. And there's the mnemonic keep, change, flip. That means you keep the first number the same, you change the sign to multiplying, and then you flip the second fraction. So 3/6 is now 6/3. Now I can just multiply across. 3 times 6 is 18. 9 times 3 is 27. So first with division, you keep, you change it to multiplying, and then you flip. Okay, so now with fractions, the last two things I want to go over is simplifying fractions and then adding and subtracting. So when you're simplifying, there's different ways you can do it. You can just solve these the way that is easiest for you, that you consistently do. It's saying simplify by prime factorization, but they just want you to simplify this fraction. Tell me what it is in its lowest terms. So if you want to do it with prime factorization, I'm going to show you what they mean. What you do is you first take the 20 and you're going to make one of those prime trees. You say, what can I divide 20 by? Well, it's even. I can divide it by 2. And then you look at the two numbers that are left and say, can I divide those anymore? Like 2, I can't divide by anything else besides 1 because it is a prime number. But 10, that's the same as 2 times 5. And then you're done because 2 and 5 are also prime numbers. So 20, my new numerator, is 2 times 2 times 5. That is prime factorization of that number. Now you do the same for the denominator. So 45, I know I can divide it by 5. It's 5 times 9. And 5 is prime. But 3, I can divide by 3. 9 is 3 times 3. So now I've broken down 45 into prime numbers. I can multiply to give me 45. 45 is the same as 5 times 3 times 3. So the last step after you have broken it down into these multiplication problems is to look to see if there's something in the numerator that's also in the denominator that can cancel out. And I have a 5 in both the numerator and the denominator. So those are gone because 5 divided by 5 is 1. And then you ask yourself what is left. So this is the answer for this one. And you can do the others on your own. But again, if you like to do it this way, great. If you have a different way of simplifying fractions, use that instead. This is a more common way. This is what I guess do, is just finding what number I can divide the numerator and the denominator by. That is called the greatest common factor. So like with 12 over 20, I can say, what's the biggest number I can divide 12 and 20 by? And you can go through different options, and I know I can divide them both by 4. So if I divide this by 4 and this by 4, that's telling me that my greatest common factor is 4, and what I get is 3/5. So in its lowest terms, this fraction is the same as 3/5. So this question is just saying, what's the biggest number you can divide 12 and 30 by? When you have a question like number 22 and they give you choices, you can look at each of the choices and test them out and say, well, can I divide them both by 15? Is that the biggest number I can divide them both by? If so, what's my new fraction? Or you can say, well, can I divide them both by 21? Or can I divide them both by 30? So you can use these choices and test them out to figure out what is the greatest common factor, and then what is the answer, what is the fraction you get when you divide the numerator and the denominator both by that greatest common factor. This is another way that they're kind of presenting this way of simplifying a fraction. They're saying if you had 16 over 40, what can you divide the numerator and the denominator by in order to get 2/5? Now this person said 4 over 4, so let's test that out. Is 16 divided by 4 2? No, 16 divided by 4 is 4. And is 40 divided by 4 5? No, it's 10. So if I divided it by 4 over 4, I would get 4/10, not 2/5. So again, you're just kind of thinking, what's the number I can divide these both by? I can divide them both by 2. So I'm dividing by the fraction 2 over 2. And then my answer is 3 over 5. So I'm just simplifying my fraction. The last thing is coming up with the least common denominators for fractions so that we can add and subtract them. So that's what LCD stands for, is least common denominator. We want the bottom number of our fractions to be the same. So what you're doing when you're finding the least common denominator is basically thinking of the multiples of those numbers. Like the multiples of 3 are 3, 6, 9, 12, 15. The multiples of 4 are 4, 8, 12, 16, 20. You're trying to find the one that they have in common. I can multiply 3 by something and get 12, and I can multiply 4 by something and get 12. So if you think of 2/3, what am I multiplying that by so that my new denominator is 12? Well, I multiply 3 times 4 and get 12. So I need to multiply the numerator by 4 as well. So my least common denominator is 12, and when I multiply it by that, I get 8/12. And then I do the same for 1/4. I want to try to make that denominator 12 as well. So what am I multiplying 4 by to get 12? 3. So I need to multiply the numerator by 3 as well. So 2/3 is the same as 8/12, and 1/4 is the same as 3/12. That's what it's asking for question number 10. They want you to find the least common denominator and then say what the new fraction is, so that they both have the same denominator. With these, when you find your least common denominator, so remember we said this is the same as 8/12, and this is the same as 3/12. So once they have the same denominator, then you can add or subtract them. The denominator stays as 12, but then you just add the numerators. And this is because if you think of it, this is saying if you have something and it's broken up and you have 8/12 shaded of this kind of pie, and then you have another one and you have 3/12 shaded, how many 12s in total are shaded? So if I had this red piece and then I have this other small little red piece, how much total, if I had a whole thing, would be shaded? That would be 11 pieces out of the 12. And that's it. So please, again, watch this recording again if you need to. Write down some notes for yourself and then retry the test. And if you don't do well, again, then please let me know and we can meet in a Zoom, or I can answer specific questions through messaging.